In this example, we'll look at how to determine the strongest type of intermolecular force that is present in a compound. So we'll look at this example, PF3. And so PF3 contains phosphorus and 3 fluorine atoms. So all of those are nonmetals. So we know that we're dealing with a covalent compound. So knowing the type of compound is important because that will help in determining what types of intermolecular forces are present. Ionic compounds can participate in certain types of intermolecular forces, whereas covalent compounds participate in others. So we know that this is covalent, but we also need to determine, is it polar covalent or nonpolar covalent? That would indicate which forces could occur in this molecule. And so in order to determine what type of covalent compound we're dealing with, we can look at the Lewis structure. And so the Lewis structure shows how the atoms are connected. It shows all electrons, whether they're bonding or non-bonding. So I won't go into detail in this particular video on how to determine the correct Lewis structure for a compound. However, there will be a different video for that, so you can refer to that video. But for now, we'll just look at the Lewis structure for this compound. And so if we went through the rules and determined the total number of electrons that the molecule should have, look at the valence electrons for each atom, figure out how they're arranged based on the atom that needs the most electrons to form an octet, arrange them, we would end up with this Lewis structure. From there, in order to determine whether it's polar or nonpolar, we could think about electronegativity. So remember, this tells about an atom's ability to attract electrons. So we can look at the values for those. So the electronegativity value for fluorine is 4.0, phosphorus 2.1. So remember, the differences in electronegativity values can indicate the type of bond that is present. So you're simply taking that larger value, subtract from that value the electronegativity of the smaller. When I do this, I have a difference of 1.9. Based on that range, that's going to indicate whether you have a nonpolar covalent, polar covalent, or ionic bond. So we've already said we're dealing with a covalent compound, but now we're indicating that the bond between the phosphorus and fluorine, because of the differences in electronegativity, it must be a polar covalent bond. Whenever you have polar covalent bonds or even polar molecules, you're going to have dipoles. The dipole indicates that there's a separation of charge. It tells you how the charge is separated. It's showing how the electrons are attracted, which of course would be towards the more electronegative atom. So that's your dipole arrow, which is showing you how the electrons in that bond are attracted. So all three of those phosphorus, fluorine bonds are going to be attracted the exact same way towards that fluorine. And so if I look at that, so even though I have these 3 bonds, 3 identical bonds being pulled in 3 directions, I also have these non-bonding electrons that are on phosphorus. So this is not a symmetric molecule. A symmetric molecule would indicate that these bonds are being pulled the exact same way throughout the entire molecule. But that's not the case. I have 3 bonds being pulled the exact same way, but I don't have this 4th bond present because I have non-bonding electrons. So in that 4th position, I don't have that exact same pull. So therefore, this represents a polar covalent compound. Knowing that it's a polar covalent compound gives us insight into the type of intermolecular force that could be present. So London dispersion forces are present in all covalent compounds. However, those are the only forces that nonpolar covalent compounds will exhibit. Polar covalent compounds will also participate in dipole-dipole interactions. Dipole-dipole just means 2 polar molecules. So it has to be polar in order for dipole-dipole forces to occur. But if you have a polar molecule, you also want to check to see if hydrogen bonding could take place. In order for hydrogen bonding to occur, you must have a hydrogen that is directly bonded to nitrogen, oxygen, or fluorine, but you also must have non-bonding or lone pair electrons that are on nitrogen, oxygen, or fluorine. So although we have all of these non-bonding electrons around these different fluorine atoms, we don't have any hydrogen bonded to nitrogen, oxygen, or fluorine. So therefore, hydrogen bonding would not occur, but it's still a polar molecule. So therefore, the strongest intermolecular force that would occur in this compound would be dipole-dipole forces.